Combinations of transformations. The order in which transformations are performed is crucial to determining the desired image, unless it states otherwise. The transformation order will always be stretches, reflections, and translations. So I think of it as I wake up in the morning and the first thing I do is stretch. Then I go to the bathroom, you look in the mirror, so there's your reflection. And it breaks down. And then you come to school and you go to Spanish or French class and you translate something. So, or that's all that's left. I've done the stretches and reflections, so. Or you can remember SRT, or I don't know, or sort of, right? It's sort of that order. Sort. Now, equations in terms of f of x can be expressed in many forms. So you're looking for, if we say answer in a specific form, then obviously that's the form in which we want the answer. So transformation form, y minus k over a, or 1 over a times y minus k, right? So that's a vertical stretch by a factor of a, move up k units, depending on the sign, is equal to f of b bracket x minus h. Right? Remember that you need, in order to get the transformations, you need this form. You cannot have 2x plus 4. You need 2 bracket x plus 2. Okay? So this needs to be in a factored form here. Okay, so one of those. Transformation parameters stay on the same side of the equation as the variable to which they apply. Okay, so everything is to work on a y. So up, down, vertical stretch, right? Y is vertical. If this is negative, then there's a reflection, right, on the x-axis. B, if B is negative, there's a reflection, right? But first we would do the absolute value of B, right? But really it's 1 over B, right? Stretched by a factor of 1 over B. If B is negative, then there's a reflection of the y-axis and horizontal translation. Simplified form, y equals. So the y is isolated. All parentheses are expanded where possible. So now this is brought into here, right? So it's bx minus, so a different constant. It's not h anymore, right? It's bx minus d. You've got the a. So on this side, the a and the k are telling you exactly what to do, right? If it's a 2, if a is a 2, it's a vertical stretch by a factor of 2. And all d is not the horizontal translation you must factor out. So in this case, it would be d over b. You factor out the b. The textbook will use these two forms for which there are no specific names. So y minus k is equal to a. So they've got the up-down, but the vertical stretch factor is on the right side. And we've got a factored form here. So similar to transformation, so right there, only the a is on the other side. And here the y is, oh, and it's got the k here. And here the y is isolated, so it's just y equals form. Okay? So pay attention to, especially if you're just looking up answers in the book and you're looking at this, but there, you turn it back and it looks like this, just take a look at what form was I supposed to be in. Okay? So there can be no questions about that. Apparently that's it. Wow, okay, hang on. And the wonders of technology. Describing transformations. So part A. Describe the transformations used to show how each of the following equations can be obtained from y equals f of x. Also show the mapping for the transformations. Okay, so we do two things. We're going to have some words, the description, vs, blah, blah, blah. And then we're going to have a mapping saying that xy becomes this. So the first thing we're going to do is get everything over. So the negative is going to go with the y. Negative y is equal to f of 1/2 x plus 1. All right, so now we can describe. So order, what's the first thing we do? Stretch it. So then I ask, are there any stretches? Yes. What kind of a stretch? Horizontal stretch. Where is this horizontal stretch about? About the y-axis by a factor of 2. Okay, is there a vertical stretch?
No.
No. Okay, so we need to look for both, right? Is there a horizontal stretch? Yes. Is there a vertical stretch? No. Are there any reflections?
Yes.
Okay, reflection about what? Okay, reflection about the x-axis. Any other reflections? Nope. Okay, the stretches, reflections, what's left? Translations. Are there any translations? Okay. What kind? Horizontal translation. Right. One. Okay. Left one. Who said right? Okay. Did I just mishear you? I'm just going to write what you say, so it's not right. Okay, now we need to do the mapping, right, which we're going to do in one fell swoop. If you want to do it in a number of steps, please do. Okay, so you got to do what makes sense to you. If you just want to say, I'm going to take x, y, I'm going to do the horizontal stretch, I'm going to do the reflection, I'm going to do the translation, and I'm going to get these four things, by all means do that. Okay, so x, y becomes 2x minus 1, negative 1. Okay. So just think about what affects x. So we've got, what do we got? We got horizontal stretch, we got vertical stretch, we've got reflection in the y-axis, reflection in the x-axis, horizontal translation, vertical translation. Of those 6 things, 3 of them affect x. So what affects x? What affects x? Which stretch affects x? Horizontal stretch. Which reflection affects x? Along the y-axis. Which translation affects x? Horizontal. Okay. So anything with the word horizontal is going to do the x, and then also reflection about the y-axis or the line. X is equal to 0, right? So anything to do with an x, there's an x in there somehow. It's a horizontal stretch about the line x equals 0. It's a reflection, or sorry, horizontal stretch about the line x equals 0. It's horizontal translation, the word horizontal, and reflection about the, again, the line x equals 0 over the y-axis. Okay, so we just worry about the horizontal. I got horizontal stretch by factor of 2. I go from x to 2x. Then I go left 1, then minus 1. Okay, and then I've got the reflection about the x-axis. Y is replaced with negative 1. Good. Question? So if at any point you have questions. 2, y minus 7 is equal to f of negative bracket x minus 3. So do we have to do any rearranging? No, right? So everything's over, right? Anything that affects the y is on the left side. Anything that affects the x is on the right side. Okay, so nothing to rewrite. Is there a horizontal stretch? I hear yes, I hear no. I will re-ask. Is there a horizontal stretch? No. Is there a vertical stretch? About what? So VS about the x-axis by a factor of how much? 1/2. Is there a reflection? What kind? Reflection about the y-axis. Is there another reflection? Is there a horizontal translation? Which way? How much? HT, right. How much? Is there a vertical translation? Which way? Up. 7. Okay, so everything is now described, right? You should be getting in the habit of I can look at any transformation equation. If I want to, I will play with it to move stuff around, and then I will state in words exactly what's going on, and there may be up to 6 things, right? Horizontal stretch, vertical stretch, reflection about the x, reflection about the y, horizontal translation, vertical translation. Right? That's all we can do right now. A maximum of 6 things. Okay, so x, y. So now I want to deal with the horizontal. So no horizontal stretch. We've got a reflection about the y-axis. So what's that going to do? So I'm going to go negative x, and then I want to move right 3. So we go plus 3. And we've got a vertical stretch, so then I'm going to end up with what here? 1/2 y plus 7, right? If you're going the other way from a mapping, again, you should be able to look at the mapping and do the same word stuff, right? Well, there's no stretch. There's a reflection about the y-axis, and then it moves right through. And there's a vertical stretch by a factor of 1/2 up there. Y equals -5. So we might want to move stuff back over. So I'm going to move everything to the left. That's, so we just have. So I'm going to start by going y plus 3 is equal to -5 f of, and at the same time I might as well factor this. Okay? So think about the form you want to be in, right? We're going to go with the 1 over a bracket y plus k, etc. form. So now what do I do with the -5? Becomes -1/5 y plus 3 is equal to f of 4x minus 2. Okay? Just one person nod your head. That'll work. All right, so looking at this. Let's do horizontal first, then we'll do vertical, okay? That's my thing. Do horizontal stretch, then I do the horizontal reflection. So I'm going to do the x's, then I'll do the y's. Okay, horizontal stretch about by a factor of 1/4, right? Yep. If I'm wrong, say something. Okay. Vertical stretch. About the x-axis by a factor of. Don't ever say a stretch is negative. Okay. Stretches are never negative. Stretches are the absolute value of anything. So, this is an upbeat class, so we must be positive. So vertical stretch about the x-axis by a factor of. Okay. Your stretches are numbered. They are positive numbers, right? They are the absolute value, because what's the negative in front of the 1/5? Okay. So there is no horizontal reflection, right? There's no reflection about the y-axis, right? There's no negative in here. So then we go to here. So we do the next. So I'm looking for the reflection about the y. Nope. Reflection about the x. Yep. So 3. Reflection about the x-axis. HT to right. I'd say about that answer, it's to right. And lastly, VT. Sorry, I started writing down before you said 3, so it's down 3. I like to mix my things, right? To right, down 3. And so we'll do this in one fell swoop, right? Let's deal with the horizontal. So we've got a horizontal stretch by factor of 1/4, so it's going to be 1/4 x. If I saw reflection, then I would put a negative in front, but there isn't. So it's 1/4 x. And then it moved right 2, so it's 1/4 x plus 2. There's a vertical stretch, so it's going to be 5y, but it's reflected, so it'll be -5y. Okay, let's just write that down first. -5y, and then it went down 3, so -3. Okay. Now, if I give you -5y, if I give you the mapping, and you're looking at -5y minus 3, then you're just going to say stretches first, vertical stretch by factor 5. Then reflects, and it's reflected, and then it goes down 3. Okay. We good? Now we wonder, will there be a blank page? No. Number 2, describe the transformations in the correct order that transform the graph of y equals f of x into the graph of y equals h of x. Here's the number one biggest thing to pay attention to. Which one's f and which one's h? Because if we give you a multiple choice question and you go from h to f, we'll put the answer there and you will gladly find it and think, got that one. And if they don't, Okay. So here's what you might want to do. Bring like a highlighter, and when it says, you see f of x, either highlight this or highlight the whole thing, right? Just say, this is what I'm starting with. Okay. Now, we need to describe the transformations in order, so we're going to start with stretches. So let's start with, well, just like vertical. So this covers 4 units, right? Vertically. This covers 4 units. So vertically, what happens? The same. Horizontally, this covers 1, 2, 3, 4, 5, 6 units. This covers 2 units. So it's a horizontal stretch by a factor of 1/3, right? It's 1/3. Okay, so number 1, HS about the y-axis by a factor of 1/3. Okay, so there's no vertical stretch, there's a horizontal stretch. Is it reflected in any way? Well, that opens down and the other one opens up. So there is a, yep.
For this one, can it reflect like both ways?
It actually does, yeah. So how do we know it reflects both ways? Yes and no, but what's the clue? Like if these were both solid dots, you wouldn't be able to tell anything, right? This is an open dot on the right. Now the open dot's on the left. How did that happen? You had to reflect it. Okay, so there's a reflection about the y-axis. Reflection about. And then you say, well, this opens down and this opens up, so then what next? There was a reflection about the x-axis. Now, maybe there's some translations. How are we going to figure that out? So we could step through this and just do step 1. Like, hey, let's do this first, and then we'll draw the next one, and then we'll draw the next. So let's do that for this. We'll just say, all right. So I'm going to ask to horizontally stretch this, which means this point goes where? Stays the same, right? Because it's on the line of stretch, right? It's on the y-axis, so this point stays here. It's by 1/3, so this is 3 units to the right, so it's going to end up here. Yeah, this point, 1/3. And this is 6, so it ends up here. So that's the first thing, right? That's number 1. Now, use a different color. So number 2, I'm now going to reflect this about the y-axis. So this point goes where? Stays the same. This ends up over here, and the open dot ends up here. So that's 2. Okay. Now, it's reflected about the x-axis. So this is 1 up. It's now going to be 1 down, and it's an open dot. This is 5 up. It's going to be 5 down. This is 1 up. It's going to be 1 down. So now we're here. So what's left? Well, what's left? 2 left, down 1. Okay. So now I got to do is say, here, where's the open dot? Well, go 2 left, 1 down. So number 4, HT left 2, number 5, VT, what did I say? Down 1. Okay, what were we supposed to do? Oh, that's it. That's what we're supposed to do, right? Just teacher never said give us the equation of that. We could write the equation of that if we wanted to, right? So we could say start with y equals f of x. And yeah, if you're going to start with y equals f of x, you could just go y equals f of 3x, and then y equals f of negative 3x, and so on, right? But it didn't ask for that, so we don't need to do that. Okay. There's another way that we could have done the translations, right? Another way. So just start with this. Okay. So I'm just going to trace out the life cycle of this point. Okay. So I'm going to reflect it about the y-axis by a factor of 1/3. Done. I'm going to I'm going to horizontally stretch it, done. And reflect about the y-axis, done. And reflect about the x-axis, now it's here. And then I'm going to move it left 2, down 1. Right. So pick an easy point. Suddenly it's on an axis is an easy point, right? Especially with all that horizontal stuff happening, because you don't have to go anywhere. Okay. You could similarly, let's just do the life cycle of this point. So horizontal stretch by 1/3. Reflect in the y-axis, reflect about the x-axis. Now I got to go left 2, down 1. Okay. So you don't need to necessarily draw out the 4 complete things. You can just say, let's take an identifiable point, solid dot, open dot, even vertex. Let's do the vertex. So horizontally stretch by a factor of 1/3, and then reflect about the y-axis, and then reflect about the x-axis. Now you got to go left 2, down 1. Okay. And all we were asked was describe the transformations in the correct order. There they are. Can I reverse these two? Yes. Can I reverse these two?
Yes.
Can I reverse these two? No. Just don't. Actually, you probably can and still get the same thing, but don't do it. If 2 bracket y minus 7 is equal to f of negative bracket x minus 3, and it's written in the form y equals a f b blah 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 blah. State the values of a, b, h, and k. So all we're being asked to do is transform. That's not even a good word to use. Change this into a different form. Okay, so here we're starting with this. I'll just put down our starting point. Square bracket. Okay, so this looks like this. Like that's good. Okay, so now we just got to get, well, let's get rid of this 2. So what do we do to get rid of the 2? So y minus 7 is equal to 1/2. And then what's y equal to? Plus 7. What's a? 1/2. What's b? Yeah, now watch that, right? I mean, it's just a negative there. Okay, there's no number, but there is a number. It's 1, so it's minus 1. What's h? 3. H is what follows a negative sign, right? Watch that. Okay, what's k? 7. K is what follows a plus sign. So we could ask this numerical response and say the sum of a, b, h, and k rounded to the nearest tenth, it has to be the half, is, okay, and then you go 10, 9, 9.5. Okay, so 9.5. We could say the product of, but that would be ridiculous and not a good numerical response, right? But read it, right? It's like, we could just say the value of k is. That'd be kind of easy. You wouldn't have to do much to get that, right? All right. Was that it on that page? Okay. Which way am I going? That way. Part B. Hey, we're almost. Just doing this for the entire period. Part B, sketching graphs using transformations. Describe the transformation the graph of y equals f of x undergoes to produce the graph of the equation given. Draw the transformed graph using the graph y equals f of x shown. And there's an A. Is there a B?
Yeah.
Yeah. There's a B. Is there a C? Is there a D? No. All right. So like on here, we'll be drawing 3 graphs. Right? Okay. G of x is equal to 2 bracket f of x minus 1. So we may want to start by plus 1. So we might want to start by translating that to g of x plus 1 is equal to 2f of negative x. Yes. All right. Horizontal stretch? Yes, no? No? Okay, I'm going with no. Vertical stretch? Oh, wait a sec. We should probably pull this out. I mean, at some point, it doesn't matter, and you can just take them off of here, right? It's just like describe it. It didn't say rewrite it in this form and then describe. It said describe them. So, you know, we can go back to this. But anyways, okay, so horizontal stretch, no. Vertical stretch, about
X-axis.
the line y equals 0. Just changing it. Right, and you might as well see that, right? Just so you don't get shocked when all of a sudden, the line y equals 0. By a factor of 2. Okay, so horizontal stretch, we said no. Vertical stretch, we said yes. Or is a reflection about the y-axis, so reflection about the y-axis. Is there a reflection about x? Nope. So what's left? Vertical translation, which way, how much, or how much, which way? One up, one down. I mean, up one or one up. VT up 1. Okay, so is that everything? Okay, now we're supposed to draw it. What color shall we use? Let's use red. How many points are we going to play with when we do this? 4 points, right? So this one, this one, this one, this one. Okay. So I'm going to do this one, then I'm going to do this one, then I'm going to join them with a straight line so I don't get lost, just in case there were like weird reflections and stuff. Then I'm going to do this one, I'm going to join it to the last thing that I ended up at, and then I'm going to do this, and so on. Okay, I'm not going to do 4 different things on it, because we got to do 3 different graphs, so I don't want to have all these things. So we're just going to go steps. Okay, so I'm going to vertically stretch by a factor of 2. Where shall I move the pen to? Up to 4, okay. I'm going to reflect about the y-axis, so I'm going to end up at here, and then I'm going to go up 1. Okay, so just start on a point, go through the list, and just do what it says. Okay, start on a point, so I'm here. Vertical stretch about line by factor, so vertical stretch by a factor of 2, I go down to -8. Reflect about the y-axis, I move from -2 to +2, staying at -8. And then go up 1. Okay, and then I'm going to join those 2 with a straight line. Okay. Actually, I forget. There's actually a line tool. I could have just drawn the line, but then I probably can't change the colors. Okay, so we did this. We did this. Okay, that's where. So now we're just going to start here. What do we do? Vertical stretch by a factor of 2, so we go to -8. Reflect about the y-axis, so we go to -2 and go up 1. Now it makes sense that that's still a horizontal line, right? So it's still a horizontal line. It is going the other way in a sense, right? Like that way, and now I'm going that way because we did reflect it. And we're going to take the last point. So Vs by 2, so from negative to -4. Reflect about the y-axis, over to -4 this way, go up 1. There's, where's that? G of x. Okay. Any questions? We can do 3 more of these just so you'll see. So all you got to do, that's why the description is the most important thing, right? And then basically, you know, you can have somebody read it to you, and then it'd be easier to follow the points when you're saying, okay, do this, yep, now do this, yep, now do this, yep, okay, put a dot there. Go to the next point. Do this, no, okay. -2/3, y equals f(x). So we don't need to rearrange anything here, right? Like we got the a on the, we got an a, y type thing. Okay. Horizontal stretch? You can say no. No. Vertical stretch? Okay. So Vs about x-axis. I'm getting lazy. I'm not going to write by a fact. By how much? 3/2. Okay. Horizontal stretch, no. Vertical stretch, yes. Any reflections? Okay. Where's the reflection? Reflect about the x-axis. Oh, this has a whole different graph. I could have done the 4 things on it, but I'm too lazy to ever do that again. Now what? Right 3. What right 3? HT. I mean, obviously if you just write right 3, then it has to be a horizontal translation, right? I just like to write HT. Really, HT, is it that much to ask of you? HT. Yeah, it's too much. I just want to write right 3. That's actually all that's written on the key. It just says right 3. I don't care, man. HT right 3. I want to know. Okay. Well, we could do this in red as well, but I have other colors. How many points are we going to be playing with here? Still 4 points, right? And I'm just going to go left to right. So, what do I do first? We're going to stretch about the x-axis by 3 halves. 3 halves is 1.5. 3 halves of 2 is 3. So now I'm at negative 3. Reflect about the x-axis. Now I'm at positive 3. And move it right 3. Okay, first point. You do the rest. I will do the rest as well, but we must now see if you're ready to leave the nest. Just going to push you out, see if you fly. You fly, or maybe birds are actually really light, so they don't, their terminal velocity is very low. And then what? Okay, verify with this, and if one of us is wrong, tell me it's me, or realize that it's you, and then say, what did I do wrong? Okay, that's good. Everybody got that? Second point? Excellent. Keep going. And okay, so is that it? Now, let's just do a little counting our way around and just kind of check stuff out here. Just say, so there was no horizontal stretch, right? Which means horizontally, this thing must be the same width. But it was moved right 3. So if I was doing domainy stuff, right, my domain would start here and end here, and now I'd add 3 to both of those numbers. So it was negative 6 to 4, so now it should be negative 3 to 7. Which it is, right? So this covers 10 units. This covers 10 units horizontally. Vertically, this goes from negative 4 to 4. That's 8. 1.5 times 8 is not 8, it's 12. This covers 12 units. This guy is 2 units long, and it's a horizontal thing. It's still 2 units long. We didn't do anything horizontally to stretch it, right? So there's this little thing about saying, so if I give you domains and you say, hey, vertically this domain covers 5 units, but this new one covers 10, then you'll say it's a vertical stretch by a factor of 2. Right? So you can take that information from, you know, what you're given. You got to take what you're given and figure out what's going on. Clean up the brackets. Write what goes in there. Don't fall asleep. It's later on. I know. It's like, is it warm in here? If it gets cold, then they panic. Oh, we're going to turn on the heat. And then it's like, now it's hot. Actually, let me turn down the heat. It's just like stuffing 40 of you into a room. But we're all little heat generators, right? Okay, so what do we have here? X plus. You could throw 1 in there, but I'm going to go with probably square bracketing. If you, it's fine. If you write 1/2 bracket x plus 1, just expand it back out. You'll get 1/2 x plus no, and then you'll change it to a 4. So it's fine. Just use a pencil, right? Make the mistake, but don't make the mistake permanent, right? Like just go 1/2 x. So you write 1/2 x plus 1, and you said 1/2 x plus no, went the wrong way, right? Okay, description. Write the description. There's a partially, and perhaps even correctly, partially filled in thing. Oh, yeah. Now we're going to fill stuff in, right? Okay, so it's horizontally stretched by a factor of 2. It's reflected about the x-axis. It is horizontal. We got to catch that stuff. Right? Okay, so it's horizontally translated left and draw it. Use blue. Blue doesn't work. Don't use blue. No, blue doesn't work. That's really weird. Blue didn't work. Okay, do it. You only got 3 points to work with. It's like easy. It's like all the other ones I was doing the heavy lifting. 4 points.
We have to change the form of it.
The form of it. Do you have to change? No. If it doesn't say change the form, it just says describe. Describe it. You just have to do it correctly. Yeah. I mean, actually, if I was going to change the form, I'd probably write p of x is negative after blah 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 plus 3. But I'm going to do that just so we get lots of practice with changing the form, right? Just so you see it enough, so that 25th you're sitting there and you're going, did that a million times, like if we always went to one form and then you're looking at the form and all of a sudden it's like this or that, could be anything. Yeah. No, I think I might have a mistake here, so just don't worry. I just yeah, no, I went. Yeah, I'm good with that. And But make my lines really thick, it'll hide the fact that I drew a lousy straight line to begin with. Here's the thing. Make sure your points are exactly where they should be and show the points. I will forgive lines that are not the straightest. Well, if you have a ruler, you should bring it in. It makes life a lot easier, right? But if your point is off, so are your marks, right? Like, it's obviously got to be at least a half off. We're having a sale on marks today, 50% off. Okay, so is that correct? Okay. Watch now. Let's. Where was it here? Okay. So show the point. The most important thing is that you get your points in the right spot, and then that you join them in the right order is also sort of important. Okay. So domain-wise, if we look, right, we should say, look, this covers 6 units, but this should cover 12, which it does. This covers 4 units, and there was no vertical stretch, so this also covers 4 units. Okay. And it was reflected about the x-axis, so instead of kind of opening down, it opens up. It was not reflected about the y-axis, so the short tail is going to the right. Log graph, y equals f of x, is given. Sketch the graph, do transformation on y equals f of x. Yeah, I don't know if I'm going to get too fancy here in rearranging the form of things. I think I'm just going to write a quick description of each thing. So just write a description and then do it. So do A. That's A, okay? Yeah? Good. Okay, so you can do B, C, D, E, F, G, and et cetera, et cetera. For homework, lucky you. Hey, I didn't sign you up for this course, your parents did. Okay, part C, writing equations. The function y equals f of x is transformed into y equals g of x. Write the equation for g of x in the form, that form. If y equals f of x is, so we're starting, again, it's all general stuff, right? Horizontally stretched about the y-axis by a factor of 1/3, reflected in the y-axis, and then translated right 5. So here's what I'm going to do. We start with y equals f of x, and we do the first transformation. So horizontally stretched about the y-axis by a factor of 1/3, what is replaced with what? One thing at a time. Horizontally stretched by about the y-axis by a factor of 1/3, x is replaced by 3x. Reflected in the y-axis, what is replaced with what? What is replaced with what? Out loud, somebody, louder, I can't hear. No, 3x. What's replaced with what? X is replaced by negative x, and how am I going to write that? Negative 3x. Right? Like I'm not going to write 3 minus x, I'm not going to write 3 bracket negative, but it's not 3x is being replaced. It isn't. It's x is replaced with negative x, and I'm going to write negative 3x. Okay? You can just write negative 3x, don't you? You don't have to think. You can think it any way you like. But I need to say, it's not 3x is replaced by negative 3x, really. That's just some kind of weird thing, right? If I'm doing inflection, I'm saying, wherever I see an x, I'm going to write a negative x. It's in there like that, I write negative 3x. Okay, and then translated right 5, what is replaced with what? So x is replaced by x minus 5. What about this? That's just there, right? What do you say? Don't, it's x is replaced by, so I see an x, I write bracket x minus 5. The negative 3, that's just there. It was always there, as far as I'm concerned. And now I'm going to replace the x. So here, this has been replaced by x minus 5, and we got to close that off. Is that in the form? No. It says y equals, I need to say g of x equals. So what's g of x equal to? let's throw the square bracket down. Okay. Now, ignoring everything that's up there except this line here, I will now describe to you, so if you come here with an answer and I'll just say cover that up, I'm going to describe to you what the transformations are. Let's see if that matches this, right? So I got a horizontal stretch by a factor of 1/3, reflection about the y-axis, and I'm moving 5 right. Okay. So anybody should be able to look at that, right? Like get somebody else, like just cover it up and say, what do you see here? Right? And they say, oh, well, you're horizontally stretched by 1/3 about the y-axis. You're reflecting the y-axis, and you're moving right 5. Good. I did what I thought I was doing. Vertically stretched about the line y equals 0. Oh my god, I don't deal with that. What's the line y equals 0? It's the x-axis. Okay. It's a vertical stretch. It has to be. You cannot vertically stretch about the line x equals 0 or the y-axis, right? If anybody ever says that, just laugh at them. Right? Or say you can't do that. Bring up. Did I show you the NHL ref thing? Yeah? I did? Okay. Yeah. So everybody says, I'm doing a vertical stretch about the y-axis. It's like, how do you vertically stretch about a vertical line? You can't. How do you move away from it? You got to go horizontal. Right? You vertically stretch about a horizontal line. Okay? In real life, it doesn't have to be the x-axis. Right now it does, right? But we can vertically stretch about any horizontal line. Right? You just do the same stuff, like how far away? I'm 2 above. Well, now I should be 4 above because I'm stretching about this line by a factor. I'm on this line. I'm going to stay on the line. Okay. Does it matter that it's the axis? Who cares? Anyways, pretty stretched about the... So, one thing at a time, because I can only handle one thing at a time. So give me a vertical stretch by a factor of 6. Give me a reflection about the what? What's the line y equals x equals 0? Okay, y-axis. So you can reflect about either line, right? You can't vertically stretch about a vertical line. Certainly reflect about. Okay, reflected about the y-axis. What do I write? Yeah. Actually, yeah, I should have been asking that all along, right? So for the vertical stretch, what do I do? X is replaced, or sorry, y is replaced with 1/6 y. X is replaced by negative x. Okay, and then translate up 7. What do I do? Get a 1/6, but instead of y, I write. Yeah. Okay. Now, it's not the form we want. Okay, so now we're going to go y minus 7 is 6 f of negative x. And then we're going to go y is equal to 6 f of negative x plus 7. Then we're going to replace the y with the g of x, because it asks for it in the form g of x equals, right? Goes, checks key, yes. Not always right. Yeah, it's both. You know, but if you do the whole replacement thing, you're less likely to make mistakes, right? So you just say, I'm going to replace y with 1/6 y. I'm going to replace x with negative x. I'm going to replace y with y minus 7. Right? Now, yeah, you could have just written 6f of x. You could have just written a plus 7 over there. But, you know, when it gets complex, really nice to have to fall back on. These are the basics. If I follow these steps in this order, it's always going to be right. Right? Yesterday I said wrong. If I follow these steps in this order, it will always, now I might mess up something when I rearrange it, but up to that point, things will be correct, right? And I just think this stretch means that this is replaced with this. This translation means this is replaced with this, okay? Don't get fancy. Y equals fx. I'm too dumb to get fancy. Vertically stretched about the x-axis by a factor of 2, what is replaced with what? Yes. Yes?
No.
No? Yes? No? Anybody agree? Somebody want to nod or you shake your head? Like I said, I see a nod. I'm going on. Okay. Okay, if I want to do a vertical stretch by a factor of a half, I replace y with 2y. Yes. It's going to become y equals 1/2 of f of x, but not yet. Okay, reflected in the x-axis. To reflect in the x-axis, I replace y with negative y, writing what on the left side? Negative 2y. Okay? And then, translated left 6, down 1. I could do that in one step, right? So because, I don't know how to draw the arrow. I have to go this way. So negative 2. Draw the arrow. Okay, so U fills in what you think ought to go there. And then all fills in what I think ought to go there. I only did that because it's really easy to change a minus to a plus, right? And they should both of them should be plus, right? Yeah. I wouldn't have done that if they're pluses, I'd have to erase them, but this way I can just say, oh, yeah. Down, left. We're almost there, right? But there's more. So now, I don't probably need brackets around that, right? And then, yes? Don't agree if you don't agree. But wait, I mean, I'll check it with this too. Anyone have this? Yeah, okay, that's good. Okay, ready to move on? Doesn't really matter, we're gonna move on. That question was rhetorical. I'm just going, I'm done, so therefore we're moving on. Because you can always play this back and slow it. I don't know what it does with the audio when you slow it down. Graph of y equals h of x. Is the graph of y equals f of x stretched horizontally by a factor of 1/3 above the y-axis, reflected x-axis, translate 1 unit left? If f of x is equal to this, then write the equation of h of x in simplified form. All right, so basically just kind of two parts, right? So we're just going to ignore this, play with that, and then we're going to do it with the for real function, okay? And again, all we're showing you is the 87 different variations of the way that things can be asked, right? It's like we're not doing anything different. It's just a bunch of stretches and that, but it's like, oh, but now, and then we're going to do it on a for real function, right? See, well, what does that do? And then you could actually graph those and then actually look at it and say, wow, look, it really did, become 1/3 of what it was horizontally, and it really did get reflected, and it really did, anyways. Okay, y equals f of x. So I'm just going to work my way down. We'll do one translation per line. So, stretch horizontally by a factor of 1/3. To do a horizontal stretch, what is replaced with what? X is replaced with 3x. Reflected in the x-axis. What is replaced with what? Y is replaced with negative 1. See, if I do this way, I don't have to think all that much, right? Like, I just have to know my replacements. This is replaced with 3x. I do this is replaced with a negative. This is replaced with a y plus 3 or whatever, right? No thinking involved. It's just very basic. I had some very basic facts in my head about how to do a horizontal extraction. Do that, and then worry about, okay, now let's get it back into the form that they want. If you just try and go into the form that they want off the bat, maybe you get it right, but maybe you don't because, because you're thinking too much. We don't want to think. We just want to say, this gets replaced by 3x. This gets replaced by -1. Okay, what's next? And translated 1 unit left. What happens now? Replace x. So hang on. So f3. Oh wait, I need like a square bracket now, don't I? 3, and then replace x with. Wait on. X plus 1. Okay, right? Cake mix simple. You see an x, right bracket x plus 1. Okay. What about the 3? Write the 3, and then I see the x, I replace with x plus 1. Okay. And then, we're going to clean that up a bit. So, clean that up a bit. We will write y equals negative f square bracket. If you put a round bracket there, I'm fine with that. Just bracket 3x plus 1. It's actually not a round bracket. What's it called? A parenthesis. The round things are parentheses. The square things are actually brackets. The curly square things are brace brackets. What did you learn in math today? Them square things is brackets. Pulls out phone, goes to Google. No, it isn't. All right, we done? We're done the last time. We're done A. Yeah? Okay, so what are we going to do with B? Here's the reason why you do the left side the way you do the left side and not by doing other fancy stuff. You are going to do the exact same things. Where I see x, what am I going to write? I'm going to write 3x. And then I'm going to, so that's the horizontal stretch, right? What do? You replace the x with, what about the -6? You see the x? You write 3x. What about the other stuff? You keep it in there, because we're not going to get rid of it, but you don't say, no. You see x, you replace it with 3x. Reflect, you see y, you replace it with -1. Okay, then what happens? Translate 1 unit left. Now what? How do I go 1 unit left? Replace x with x plus 1. Okay. Stick the x plus 1 in parentheses, right? Because you're replacing one quantity with another. That quantity's down. And then what do I write? Okay. And now we get to clean it up. And did it say h of x? Or? Yeah, h of x. Okay. And if you left that as negative in the absolute value of 3x minus 3, that'd be okay too. Okay, so just say or. Okay, so either one, whatever's in the absolute value, you can leave it as 3x minus, assuming that that's actually correct. Yeah. But if this is right, then you can go. Yep. Where did the 6 go? Oh, what's this expand to? 3x plus 3 minus 6. Too much? Yeah.
The equation on the left says to put in simplified form.
In simplified form. What? Which one's that?
On the left.
Yeah, I know. That's like 6 pages back. What's simplified form?
You have to. Yeah.
Oh, you're right. Yeah, simplified form. Oh, well, in that case, then this should be in simplified form too, right? My bad. Okay. Sorry, my bad. Simplified form, so that means the brackets are expanded. You don't factor the x term inside the thing there, right? Thank you for paying attention. Okay, 8. Wait. 8 or wait? Wait, then 8? That we're falling behind. There's no behind. We got a lot of time tomorrow too. Okay, I got a thumbs up. I'm going on. Remember, all the answers are the PDFs of almost correct answers. I've seen a few things where it's like whatever, and extraordinarily long, boring video. Even at double speed, it's still going to be. I love the voice. I should do helium and double speed. Okay, the graph of y equals p of x is graph of y equals m stretched vertically by factor, blah, blah, blah. If that was in, write the equation p of x in the form, okay, at least they gave us the form, and then in terms of x. So, same thing, right? Okay, but we know what form we're going to end by. I'm still just going to, so I'm going to start with y equals p of x. No, y equals f of x, sorry, that's our starting function. And we're going to do, so stretch vertically by a factor of 2. What's replaced with what? Y, 1/2 y. Okay. Then what about this? And reflected in the y-axis. Reflected in the y-axis will be negative x, right? X is replaced with negative x. 1/2 y. And then, oh, really? That's it? Wow. Okay, and we got to get it in the form, so we're just going to go y is equal to 2f of. So then, we didn't want y, right? We wanted p of x. Okay? Yes, okay. It's all right, it's all right. Okay, now what? There are a set of rules. Follow the rules. Do not question the rules. Do not question yourself. Just do it. It'll all work out good in the end, right? Okay. So what's the first thing? We replace y with a 1/2 y. Thank God. That's like really easy, right? Okay. And now what do? We replace. So everywhere I see x, I'm going to write negative. Everywhere I see x, you see an x, replace it with a negative x. I'm actually going to kind of more explicitly do, yeah, right? I mean, I wouldn't write that in general, right? Okay, I would probably just go straight to this. Okay, I'm likely to go from here to here, yeah? As are you. But just see that you see an x replaced with a negative x. When you replace something with something, stick brackets around it if you like. Say, I saw an x, I'm going to replace it with a negative x. And then, okay, we done? Yes, we're done. No, we're done. No,
How do you know that the negative 2x there is like the 2 is from the y and it's not just.
I have to multiply both sides by 2.
Yeah, I know, but how would you know if you just read it that it's not the.
Oh, yeah, you wouldn't, right? Well, I mean, with for reals functions, you sometimes can't tell a horizontal stretch from a vertical stretch. Like, it could be either. Right? Depends on the function, like especially a parabola, right? Think about a parabola. Okay, here's the problem. I'm stretching horizontally. No, you're not. You're stretching it vertically, but you're compressing it. I'm stretching it vertically upwards. No, you're not. You're narrowing it horizontally. You can't tell. We've done, not quite. So P of X. Let's flip this around and let's toss in a restriction, right? Which we also could have tossed in on this original here. Go. 1. See, now x can't be negative 1, right? Like originally x couldn't be 1, now x can't be negative 1. If f of x is 3x squared and g of x is 1/3 of f of negative x plus 1, then write the equation for g of x in simplified form. That's too hard, I can't do that. Oh, goodness gracious. What are we going to do? Okay, what's g of x? It's 1/3 f of negative x plus 1. But what's f of x say to do? It says take whatever's in the brackets, square it, and multiply it by 3. So then take whatever's in the brackets. So it's going to be 3 times whatever's in the brackets. Okay, now here let's separate these like this. Okay, let's bracket that. So this bracket is f of negative x plus 1, right? If you see f of negative x plus 1, you may replace that with 3 times negative x plus 1 squared because that's the definition of f of x, right? It says take the input, square, take whatever's in the bracket, square it, multiply it by 3. Okay, and then we should be able to simplify that a little bit. Because 1/3 of 3 is 1. So there's g of x. It is negative x plus 1 quantity squared, right? Open parenthesis, negative x plus 1 squared. Which is, so if we want to, so it says simplified form, so we got to expand that out, right? So what's that? X squared minus 2x plus 1? So we're just going to square the binomial, right? Yeah. We'll do one more, then we'll stop. Right? Or the bell will go in the middle of doing the next one. We'll stop. 10, 20, 30, 40. No, 39. Okay. I might be missing somebody. All right. Last one that we're going to do today. The graphs of y equals f of x and y equals h of x are shown. Make sure you know which one's which and where you're going from where. What am I starting with? What am I ending with? If h of x is the transformed image, so I'm starting with f of x, which is the graph on the left, and I'm going to the graph on the right. Write the equation of h of x in terms of f of x in simplified form. So what I'm going to want to do is describe what transformations happened to go from here to here, right? Make sure you know. So bring a highlighter, circle that, right? And then say, I'm going to this. What type of transformation should we look for first? Should look for stretches. I like horizontal. So this horizontally, this goes 1, 2, 3, 4 units. Horizontally, this goes 1, 2, 3, 4 units. So how much horizontal stretch was there? There wasn't one. Vertically, I think it's obvious it's been stretched. 1, 2, 3. 9. So, vertical stretch about by a factor of 3, right? Original function covered 3 units vertically, transform covers 9 units vertically. You got vertical stretch by factor of 3. Okay. Now, A ended up at A prime, so A was on the left and now it's on the right, which means there had to be a reflection in the y-axis. It collects rainwater, and so does the other one, so there was no vertical, right? So no vertical reflection. So then, how did you move? So why don't we just take point B, do 1 and 2 to it, see where we end up, and then figure out how do we get to B prime. Okay, that's all I need. So here's B. All right, what happened? I vertically stretched by a factor of 3, so I was at -2. Now I'm at -6. I then reflected about the y-axis, so I'm at +2. So then I went right 1, up 1. HT, right 1. BT. Okay. What was the actual question asking us? Transformed into. Okay, so now we got the description. We just have to take f of x and write it as h of x. Okay, vertical stretch means that I replace y with 3y. Wait, was it by 3? So 1/3 y. Reflection about the y-axis. And right 1, up 1. Up 1. And right 1. These should be square brackets. Well, just brackets, right? Because brackets are square. Okay, what form? Simplified form. Which one is simplified form? Is that like y equals? Simplify with, so you expand the brackets out? Yeah, okay. Okay, so y minus 1 is equal to 3 f of, so if I expand the brackets, then that's going to be -x plus 1. So y is equal to 3f -x plus 1 plus 1. And was it actually h of x? So then in the end, the last thing we write. So remember back in 20 when they said, yeah, no more 45-minute classes because they didn't go bell to bell? We weren't lying.